Hey, fourth grade, it's Mrs. Seals back for our next science lab. So we have finished up our unit on energy, and for the next couple of weeks, we'll be doing another unit on force and motion. So let's go ahead and get started. It says pushes and pulls. So today we're going to be doing an investigation to explore the effect of force on an object, such as a push or a pull. So hopefully you remember from kindergarten, first and second grade and third grade that force is a push or a pull that can change the position or motion of an object or material. And motion is the change in position of an object. So some words we can use to describe motion are round and round, spinning, straight line, back and forth, up and down, side to side, and zigzag. All of those describe the way objects move. So today we're going to be doing an experiment to see how position and motion are changed by pushing and pulling, and also to see if maybe mass has an effect on the force of an object, okay? So today we're going to be doing an investigation called ping pong poppers, and we're going to see some pushes and pulls. So to do this investigation, we're using something that looks like this. This is the popper. Uh-oh, hold on, dropping stuff over here. All right, so this is the popper. You may have seen these before, and the way it works is you flip it inside out like this, and then you put whatever you want to push up in here, and you set it down, and then when it releases, if it ever, there we go, it pushes whatever is in it up. Okay, so it's applying force to push something up. So this is called ping pong poppers. So we're going to be using the popper to push 3 different things up. The first thing, obviously, is a ping pong ball. Since it's called ping pong poppers, ping pong balls are very light. They don't have a lot of mass. They are hollow on the inside. We're also going to be using a bouncy ball, which is, we all know what a bouncy ball is, right? This is a Halloween one, so it looks like an eyeball, but it's just a little rubber ball that bounces. Okay, and a golf ball. Yikes, golf balls have a lot of mass. They are very dense inside. So I keep using this word mass. Let's make sure we all remember what this word means. We talked about mass at the very beginning of the school year when I believe everyone was learning virtually. I made a video about about what mass is and how to measure mass using a primary balance and a triple beam balance. So remember, mass is the measure of how much matter is in an object. It's not the same as weight. Weight depends on the gravitational pull. So your weight is different on Earth as it is on the moon because those things have different gravitational pulls. However, mass is not affected by the gravitational pull. It's just a measure of how much mass is in an object. So that will not change depending on the gravitational pull. You would have the same mass on Earth as you would on the moon. All right, so mass is a measure of how much matter is in an object. So we are going to do an investigation to see if mass affects the amount of force on an object. So before we use the poppers to push these 3 things up, we are going to find their mass. I'm going to measure the mass of each of these objects. All right, so I'm going to use a triple beam balance. Hopefully you remember. I'm not going to go into a lot of detail on reminding you how to use this today. But you do need to know how to use it. So if you have forgotten, there is a video from, I think, the 2nd or 3rd week of school where, I think it was the 2nd week of school, where I told you how to use this. So please go back and watch that if you don't remember. Because I'm going to do this quickly because the point of this isn't how to use a triple beam balance. The point of this is to see how mass affects how high these balls will go. Okay, so I am putting this coffee filter on here, and the only reason I'm putting this on here is when I put my different balls on here, I don't want them to roll off. So the coffee filter is just going to help keep them in place. So I have to calibrate with my coffee filter on here. So in other words, I won't be finding the mass of the coffee filter. I'm going to make sure these are lined up with my coffee filter already on here. I don't even know if I'm going the right way. I can't really tell. All right, that looks pretty good. Let's start with our bouncy ball. We're going to find the mass of the bouncy ball. I'm going to put it on there. All right, so this one up, remember I start with my hundreds, and I need to listen for it to click into place. Way too much, right? So I'm going to put my hundreds back and go to my tens. Again, I want them to click into place. Not enough. Too much, so I'm going to go back to 10. And I'm going to carefully slide my ones over until my until I'm lined up over here. I think I need just a tiny bit. Keep moving it. Sorry. I need to move it like 1/10 of a gram. All right. Looks pretty good, right? So now I need to add up my numbers. Remember, this is where we use expanded form. We don't have any hundreds. We have 10, and then we have 1 and 8/10. So 10 plus 1 is 11, and then my decimal would be 8/10. So 11 and 8/10 grams. So that would be the mass of my bouncy ball. I'm going to write that down. Bouncy ball. And we're going to round up for this. So we're going to round 11 and 8/10 is almost 12. So we're going to round up to 12 grams. All right. So our bouncy ball is a mass of 12 grams. Let's find the mass of our golf ball now. So I'm taking out my bouncy ball, putting everything back to 0, carefully adding my golf ball. I don't know if there we go. All right, starting with my hundreds. Way too much. Back. Let's do our tens. Didn't even move. All right, I'm at 50. 50 is too much. I'm going back to 40 and using my ones. Too much. Whoa, yikes. Maybe a little tiny bit more. All right, looks pretty good. So I don't have any hundreds. And then my tens are at 40. And then my ones are at 5, almost to 6. So we're going to round up to 6. So 46. So the mass of my golf ball is 46 grams. So my bouncy ball was 12 grams. My golf ball is 46 grams. So my golf ball has a lot more mass than my bouncy ball. All All right, we have one more, which is our ping pong ball. It's the one that feels very light. Woo. Putting it in. I'm not even going to try with the hundreds because I know it has less mass than the golf ball, and the golf ball wasn't even 100. Let me start with my tens. Oh, look at that. My 10 was too much. So I'm going to put it back. Now I'm going to use my ones. Looks pretty good. All right, I don't have any hundreds or tens. And then I'm at 2 4/10, so that would round down to 2. So my ping pong ball has a mass of only 2 grams. Wow. All right, so let's review. Bouncy ball, 12 grams. Golf ball, 46 grams. Ping pong ball, 2 grams. All right, so my golf ball has the most mass. My ping pong ball has the least mass, and then the bouncy ball's in between. It has less mass than the golf ball, more mass than the ping pong ball. All right, so are you ready? Before we do the experiment, I'd like for you to make a prediction. Miss Seals would not spend all this time measuring mass and finding the mass if mass was not going to affect how high these balls are pushed. So I want you to make a prediction. I want to know, do you think that the ball with the most mass is going to be pushed the highest from the popper? Do you think the ball with the least mass is going to be pushed the highest from the popper? Or do you think the ball in the middle, less mass than the golf ball, more mass than the ping pong ball, is going to go the highest? Go ahead and make your prediction. Think about how when you're moving something or when you're picking something up, is it easier to pick up something hard? Is it easier to pick up, is it easier to pick up something heavy? Is it easier to pick up something light? Does it not matter? That's what I want you to think about. So we're about to do the investigation. The kids in class will be doing this. Each table group will get these materials. We are wearing goggles to be safe during this investigation. We don't want to get hit in the eye with any of these objects. You know, we just got to be safe. So that would really hurt to get hit in the eye with a ball. So I am putting on goggles. All the students will be too. I'll be sanitizing the goggles between each class to make sure they are clean and ready to go. All right, so I'm going to do the best I can. I know that it might be hard for you to see, but you know, we're doing the best we can with this virtual stuff. So I'm going to start with the bouncy ball. So remember, the bouncy ball had a mass of 12 grams, has more mass than the ping pong ball, less mass than the golf ball. Are you ready? So what I'm going to do is I'm going to put the bouncy ball, I'm going to flip the popper, I'm going to put the bouncy ball in it, and I'm not going to let it go until I set it down and I'm ready. All right? So you're watching. I think I'll do it about right here. Give it a second. Sure is, oh, there we go. Wow, it sure took its time, didn't it? So I don't know if you could see, but the bouncy ball went about right here, a little bit higher than me. I'm 5 feet tall, so the bouncy ball maybe went, I don't know, 5.5 feet tall. It didn't go all the way to the ceiling, okay? It went to about here on me. The angle might be weird, so it might have looked like it went higher to you. I don't know. But in real life, it was about a foot above me, okay? That was the bouncy ball. The next one I'm going to do is the golf ball. This is the very heavy one, the one that had a mass of 46 grams. So make sure you're watching, all right? I'm flipping the popper, putting it in. All right, hopefully you could see that. The golf ball came to about a little below my knee. So it was maybe about a foot or a foot and a half off the ground, all right? So remember the bouncy ball went to about a foot above me, or half a foot to a foot, and the golf ball went to about my knee, okay? Now we're ready for the ping pong ball, which is the one that is very light. It only had a mass of 2 grams. All right, so here's our last one. Here's the ping pong ball. Whoa! Did you see that? Hopefully you could see it on the video. If you couldn't see it, hopefully you could hear it. But the ping pong ball hit the ceiling. It went all the way up to the ceiling. All right, so let's talk about this, because I think there is a correlation or a relationship between the mass of these objects and how high they went. My golf ball has the most mass, and it barely got off the ground, right? The popper tried to push, couldn't push it very far. It barely got, to my knee, but it has the most mass. The bouncy ball has less mass than the golf ball, and it went higher. It went to about a little bit above my head. And the ping pong ball that has the least amount of mass went the highest. It went all the way to the ceiling. So there's a relationship there. The more mass an object has, the less it went off the ground, or the least distance it was pushed. The less mass an object has, the higher it went and the further it was pushed, okay? And we saw pushes. We saw the popper pushing all 3 of these objects up with the same amount of force. We also saw a force pulling them back down to the ground. That is a force called gravity. Gravity is a force that pulls things towards the center of the earth. That's what keeps us on the ground. If we didn't have gravity, we would just be floating all around. And if you trip and fall, you wouldn't get hurt because there'd be nothing pulling you down to the ground, right? So gravity is what pulled all 3 of these things back down to the ground. So we saw pushes, we saw pulls. And my question for you now is, what would I need to do in this experiment? What would I need to change about this experiment to get my bouncy ball and my golf ball to go as high as the ping pong ball? What would I need to do to get them to touch the ceiling as well? Do you have any ideas? The answer, hopefully what you were thinking, is that I would need to apply more force to them. I applied the same amount of force. I used the same popper. I applied the same amount of force to all 3 of these. So the one with the least mass was the easiest to push. The one with the most mass was the hardest to push. So in order to get the heavier objects, or the objects with more mass, to go as high as the object with the least mass, we would need to apply more force to them. All right, I hope that you had fun with that experiment. I look forward to next week when we will continue talking about force and motion. I hope you have a good rest of your day. See you next time. Bye, guys.